In the last video, we constructed this two-observer diagram, and we saw that in the at-rest frame, in Anna's frame, the moving stick has a length that's less than 4. Right? It's 4 in the moving frame, it's less than 4 in Anastasia's frame. And in this video, I'm going to come up with a formula to show us how much less it is. We'll come up with the x coordinate for event B. So what I'm going to do is just focus in on this region of the graph and recall this. So let's see. So we're going to zoom in like this. And here's the picture. So remember, event A has a spacetime coordinate in the moving frame of 4. I'm going to break that over here, I guess. X prime A is 4 nanoseconds, or I'll just write 4. And the time at which that occurs is 0. Everything along the x prime axis is simultaneous. It happens at t prime equals 0. So, t a prime is 0. And what I would like to do is I'd like to find the coordinates for B in the unprimed frame, in x and t, not x prime and t prime. So here's what we'll do. I'm going to use the Lorentz transformations to convert this into the black at-rest Anastasia frame. Then, once we have that, we can do just a little bit of geometry, and we'll be able to figure out the value for xb, which is the length of the stick in Anna's frame. All right. So, in particular, what I'm going to need is I'm going to need the coordinate, the time coordinate for event A in the unprimed frames. So we're going to use the Lorentz transformation for t. So this lets us translate from the primed frame into the unprimed frame. And this will be for event A. And I want to know the time coordinate in the unprimed frame. All right, so this is the time that Anastasia sees event A as taking place. All right, so let's see. T prime is, oh, that's 0. That's nice. That goes away. And x prime, what is x prime? X prime is 4. And I'm going to keep this, I guess, symbolic. I'm just going to call that x prime A. Actually, that's going to be gamma, beta, x prime A. Okay. So TA is this. So that's going to be this, this height. Maybe I'll label that. Let's call this TA. So that's from here to here. And what I want to figure out next is this distance, right, the base of this triangle. And I couldn't figure out what to call this, so I decided to call this delta x. That's a little change in x. Because it's not, I don't know, it's not a big change in x. I don't know. I'm not happy with that, but that's what I decided to call it. Okay, so I want to figure out this. So the thing to remember, and I didn't draw this here because it was going to get too cluttered. A and B, they're connected by the world line of the right side of the stick, and this moves at a speed of beta. Beta is 2/5 in this case, but it moves at a speed of beta. So what that tells me is that beta, that's the speed of the right side of the stick. That's going to be how far it goes in the x direction divided by how far it goes in the time direction, distance over time. Delta x over TA. And so delta x, that's what I'm looking for. Just move TA over to the left, is beta times TA. Oh, and I know what TA is. I just figured it out here. So let's write this. Beta TA is gamma beta x prime A, gamma beta x prime A. So many Greek letters. We can at least scrunch these two together. So this is going to become beta squared gamma x prime A. All right, so we're getting there. But what I'm ultimately interested in is not this, but this. But here's the thing. I know this distance. I know this distance. And so this big distance minus this little distance gives me that. And this, this distance is going to be xb. Okay, so this distance here is xb, the x coordinate in Anna's frame for event B, and it's also the length of the stick. So this is what we call delta x. And if we take delta x, all right, let me write this. xb all right, so xb is this length minus that length. That's what this says just in algebra. And good news, we've got a formula for this, and we've got a formula for that, so we're almost done. Okay, so gamma, all right, so delta x is gamma x primed, and delta x prime is just xa. So I'm going to write this as, let's see, this is going to be gamma x prime A. And then we're going to subtract from that a delta x. Delta x is this thing, gamma beta squared x prime A. I just put the gamma out front. So then I notice, oh, you know what? There's a gamma and an x prime on both of these things. Well, isn't that interesting? So I'm gonna, I guess, write this like this: gamma x prime A 1 minus beta squared. All right. So just a little bit of algebra left, and then we'll collect terms and write things in a slightly different way and declare victory. All right, so gamma, let's write out gamma. So this is still xb, and gamma is 1 over square root of that. And a square root is the same as a half power. I'm going to write it this way. And then we've got x prime A, and then also up top we have a 1 minus beta squared. Hey look, we've got a blah divided by a blah to the half. So this is something to the 1. This is blah to the 1. This is a blah to the half. So we subtract exponents. 1 minus a half is a half. So this is just x prime A 1 minus beta squared to the half. And let me just write this in a slightly different way. So xb is 1 minus beta squared square root x prime A. All right, so this is what we're worked towards. And the last thing I want to do is write this in a more familiar way. Although maybe this already looks familiar. If not, it'll look more familiar soon. X prime A, what is that? that's this. That's the length of the stick in Beowulf's frame, and the stick is at rest in Beowulf's frame. He's carrying the stick with him. And so x prime A is the rest length. LR. And what is xb? That's the length in a frame in which the stick is not at rest. So that's going to be L. So this, let me just write this. This is rest length. And then this is and the picture here is of the object. And so we end up with a formula that looks just like the form that we had before. Okay, so what this shows is that the following two scenarios are the same. So Anna is at rest, Beowulf is moving by. Anna measures the rest length for the stick. Beowulf measures a stick that's contracted, that's shorter, by this amount. Or Beowulf is moving at a speed beta. Anna is at rest. Beowulf measures a stick that has its length rest length of 4 because the stick is at rest in his frame. And then Anna would measure the moving stick as having a length that's contracted by the same amount. So the moral of the story is that there's a symmetry here. It doesn't really matter if the stick is at rest and you've got somebody moving, or you're at rest and the stick is moving. Of course, those situations are the same from the point of view of relativity. Beowulf just as well could have, when Beowulf is moving this way, that's how Anna would describe it. Beowulf would see himself at rest and would say, whoa, Anna's moving that way. In any event, the length contraction formulas, we have them here, we've re-derived them, they're symmetric.